Okay, let's discuss rational expressions. Let's say you had this problem. What would you do? It's a multiplication problem. If it helps you, just add some parentheses, and maybe that will help you see it as a FOIL problem. So let's do the top. Our first, x times x, is x squared. The outside, x times 2, is 2x positive. The inside is negative 1x. And our last term, negative 1 times positive 2, is negative 2. Let's combine our like terms here. And that will equal, move my chart over, x squared and 1x minus 2. Okay, let's see if we can do the bottom the same way. Add parentheses if it will help you. Our first term, x squared. Our outside term, x times 3, is 3x. Our inside term, 1 times x, is 1x. And our last term, 1 times 3, is 3. Let's add our like terms. So we're going to have x squared here's our like terms. 3x plus 1x is 4x. And 3. That's all there is to this work. You just FOIL it and move on. Let's try simplifying a small example. Say you have 7x and 21 over 7. Do you see a number that is common to 7x and common also to 21? How about the number 7? And remember, when we're factoring, you would sort of pull out the 7 and put that on the outside of a parentheses. And when you pull it out, you're dividing. In other words, you're saying 7x divided by 7 is x. 21 divided by 7 is 3. And if you're worried if that's correct, just go back and distribute your 7. 7 times x is 7x. 7 times 3 is 21. So you see we did distribute properly. Okay, our denominator is still 7. There's no further way we can simplify that. And now we can cancel out these two 7s, and we're left with x plus 3. How can we cancel out the two 7s? Well, maybe you remember in grade school math that any number over the same number equals 1. So if we changed this to a 1 and this to a 1, because it's still any number, a number over the same number, we're essentially saying that we have 1 times x plus 3. And of course, we don't have to write 1. We can just write it as x plus 3. Okay, I'll be back with some more examples.